Oh, you're ready for me? Oh, okay, I'm sorry, I didn't realize that you were rolling already. Um, okay, so let's see, what were we gonna do? We're gonna do the fun facts about the cross product. So let's get right to it. We have some fun facts about the cross product. These are just properties of the cross product. So first one, u crossed with v is orthogonal to both u and v. So if you have two vectors and you work out the cross product of those two vectors, it will be perpendicular to both of the original vectors. We discovered this on our last video, that u crossed with v is the negative of v crossed with u. We sometimes call that anti-commutative. So you can switch places, but only if you negate something. So anti-commutative. Anyway. So this is kind of an interesting fact, and we won't prove this geometrically, but it is sort of related to the dot product rule that you have the cosine for dot products. Here, the sine, the magnitude of u crossed with v is the magnitude of u times the magnitude of v times the sine of the angle between the two. And actually, once you know this, you can also conclude that here we have this thing that if you have the two are parallel, then the cross product will be 0. But this one here, right here, this one is related to this. Specifically, if you have two vectors and you work out the cross product, its magnitude will actually be the area of this parallelogram here. And the reason we know that is because the parallelogram's area is actually the, so we'll call this height and this base, the base times the height. You know this formula from geometry. And so the magnitude of this vector times the sine of this angle will be the height. And then the base is just the magnitude of that vector. So anyway, magnitude of u crossed with v is the area of a parallelogram, which has u and v as its sides. Now this one's even crazier, but this is sometimes called the triple scalar product. You have the magnitude of u dotted with v crossed with w is actually the volume of the parallel pipette, whatever that is. Now I'll show you what it is. It's just a box that's been pushed over on its side. Let's see, we'll maybe do a new, whoops, that's not what I want. There we go, make a new drawing here. So we have u, and I'll put v kind of going back into the screen, and then here's w. So you have to imagine that this is the front face of this parallel pipette, and each of the sides of the parallel pipette are, well, these vectors. Okay, that's sort of what it looks like. So anyway, it's a parallel pipette is just if you think of a shoebox that's been sort of squished over on one side so that it's at an angle, so that the sides are no longer rectangular, but they are parallelograms. Anyway, so if you have three vectors, the volume of that parallel pipette would be this triple product of the vectors. By the way, going back, just let me go back to this really quick. Since you know that this is the area, that the cross product is equal to the area of this parallelogram, here's u and v. If you want to know the area of this triangle, it's just half of the area of the parallelogram. So if you take the magnitude of the cross product and divide it by 2, you'll get the area of this triangle. Anyway, one more, and this is more of the physics thing, that u crossed with v is the torque generated by applying a force to a terminal end of a lever. So if I have a wrench or something that I'm pushing down, then the torque that I produce at the axle will be equal to the force times, or cross product with the lever, if you will. So this next example is exactly that. I've got a bicycle here. This is not me. This is just some stock photo of a bicyclist. And I'm going to just say that this is 9,800 newtons that are being pressed down. That's approximately the amount of force that I am. My weight is 9,800 newtons. So pressing down on this pedal, and the crank arm is approximately, well, it's about 175 millimeters long, so 0.175 meters is the length of this. And then one last thing is the angle between these two is going to be 20 degrees. So we can do this one of two ways, but I'll do it the easy way. I want to find the amount of torque that is going on. Let's see, I need a different color. How about this? So I need the amount of torque at that axle. So the way you're going to compute the torque is it's going to be the magnitude of F crossed with D. Well, in this case, I'm using V, but wait, what did I use back here? U. Okay, so I guess I better keep myself straight here. So let me erase that. And I'll just have it be exactly the same. So we have U crossed with F. That's better. Doesn't matter because of the absolute value, but there it is. So the way I'm going to do this, the easy way, instead of having to, I mean, I could do this. I could say that the force is this vector. We're pointing straight down, so that's 0, 0, 9800, oh, negative 9800. And then this vector here, V, let's say that you're going 0 in the x direction, and then you have to figure out the y and the z based on this angle and the length. Way too much work, because we already have this, this formula on the previous page that said that the magnitude of this cross product is the magnitude of u times the magnitude of f in this case, times the sine of the angle. So this is going to be way easier. So I'll just do it this way. So in this case, we have the force, or no, the magnitude of, well, it's V, is 0.175, and then the force is 9800, and then the sine of 20 degrees. And that'll be the amount of torque. So Newton in Newton meters. Torque is measured in Newton meters. So let's just punch this into my calculator. I have 0.175 times 9800 times the sine of 20 degrees. Am I in degrees? I am. So 20 degrees, and my answer is 586 Newton meters is the amount of torque. All right, well, just let me know if you have questions about any of this moving forward. You know where to find me in the classroom on Monday or Wednesday or Tuesday. So just, let me know how things are going.